This is Professor Darif Seitz. This Java tutorial focuses on polymorphism. Here's the class diagram for the example we'll be looking at. We have a boat base class and 4 derived classes: a canoe, motorboat, rowboat, and sailboat. Polymorphism literally means many forms. It's a technique whereby you can use a base class reference, and just using that one base class you can iterate through a list of derived objects that are referenced by that base class and get the different behaviors that they provide without having to write all different code for every different derived class. Let's look at the code to understand this better. Here's the base class, boat. We're interested in which of its functions are overridden by its child classes. The annotations here point out that display specs is overridden, draw side view is overridden, draw top view is overridden, and also the toString function is overridden. Notice for that one, toString is overridden, and it's also an override of the version of toString in object, the root of all the Java classes. Looking at one of the derived classes, sailboat, it overrides display specs, it overrides draw side view, overrides draw top view, and not surprisingly, because we saw this in the base class, it also overrides toString. Looking at a client that exercises these classes, boat polymorphism client, we have here, first of all, an array list of boats. Notice that the boat is the base class, so we have an array list that will hold base class references. It's called list boats. We instantiate it, new array list. There's the diamond operator. The comments say that we're going to add 2 canoes to the list, 1 rowboat, 1 motorboat, and 2 sailboats. Looking at the canoes first, the first canoe, the object that we're going to use here is called canoe. We instantiate a canoe, and since the constructor doesn't take all the possible fields, we use 2 of the setter methods inherited from the base class to change the hull material to fiberglass here and the number of anchors to 0. So these 3 statements are setting up our object, a canoe object, but then we're adding it to our list of boats. So in the list it's going to be referenced by a boat, because the canoe is a boat. It's a child, so it is a boat. It can stand in the place of a boat, but in the list it will be the boat or base class reference that will be referencing it. The second canoe, we're not interested in changing any of the other fields like we did in the first one. We'll just take the defaults from the constructor. So this, we don't need a named object. Notice here just the new canoe. This is called an anonymous object. Doesn't really have a name. We just add it to our boats list. We had a rowboat, also an anonymous instantiation. We had a motorboat where we do set a couple of the other fields and have a named object that we put in our list. Two sailboats, one with a named object and the other one with an anonymous object. Now we have everything that we are interested in for this example in our list. We use an enhanced for loop. The thing that's going to be available in the loop is this boat reference called boat, and it's going to be a reference into list boats. We display the specs for the boat and then print a blank line. We print out a label onto the system console, a message saying side view, then boat draw side view, a blank line, another message or label, and boat draw top view. So notice this for loop is not very large, very small, and we can handle all these different boats polymorphically through this base class reference. Let's run it and scroll up to the top of the output, and we see here our first canoe, side view and top view. It's called the Mohican that we named it. Second canoe, the Wyandotte. The rowboat named Swanee. The motorboat Purple Haze. The first sailboat Spirit. And the second sailboat Tempest. So again, going back to the code, this is the power of polymorphism. Once you set up a list, the code is the same to manipulate all these different objects to get this many behavior from this one base class reference.